So, you need to listen. And my joke of the day was, I'm getting old and my workouts are getting harder and harder. I think I'm beginning to fall off the physical cliff. Okay, thank you. Oh, I told it yesterday? No, that was today I told it. Oh, okay. Okay, but so let's hide this somewhere. All right. So we're going to learn about exponential functions. And exponential functions are functions of the form y equals a to the x. And you may recall that if I graph exponential functions, or you just learned this today, right? If you just graph an exponential function, they kind of go up fast like that, right? And when they say things are growing exponentially, they go very, very fast. And in some cases, they come down, and then they fall kind of very, very slowly, as in radioactive stuff, right? Isotopes and stuff. The radioactive decay, it happens over very, very many years because it's an exponential function where it's decreasing exponentially rather increasing exponentially. So, you guys, so an exponential function of this form you may have learned in the lab. If it's y, or in the lab that we just did, this would go through the point 0, comma what? If this is a 0, comma 1, and all exponential functions of this form, at least if you're not adding or subtracting, they're going to go through 0, comma 1, unless I throw a negative side, right, which makes it go through -1, and it has an asymptote at where? You discovered this. At y equals 0, which you discovered in the lab 2, meaning it approaches the x-axis, right, this way, or this way if this is negative, no, if this number is less than 1, right? And what else do we know about it? They have a domain. Who could tell me the domain of this particular exponential function? Yeah, it goes from negative infinity. Oh, you're changing things. Negative infinity up to infinity. And the range goes from where? Not 1, because it's
greater than 0.
Greater than 0. So it would go from 0, not including 0, up to infinity like that. So that's one way of writing the domain of range. It has a point 0, 1. It also has a point 1, comma. If I plug in 1 in here, what do I get out? A. Thank you. It'll have a point 1, comma a. So if this, for instance, were instead of being a to the x, it were like 2 to the x, it would have the point 1, comma 2, right? And then it also has a point back here, -1. It also has a point -1, comma 1 over a, because that's an a. Can you tell that's an a? 1, not a 2. -1, comma 1 over a. Because if I were to take this and plug in -1, you may recall from, I figured it out. When I turn that way, my Mobi board doesn't work anymore. Probably because the receiver is pointing the wrong direction. I figured it out. Okay, so if I plug in -1 in here, right, anything raised to the -1 is the same as 1 over that to the first power. So an exponential function has a point -1, comma 1 over a. So if this were y equals 2 to the x, it has 1, comma 2, right? And it would have -1, comma 1 over 2 if that were y equals 2 to the x. So those are some things about exponential functions. Also, we learned some things about what effects the various numbers have on this. So sometimes they'll put a number in front, which we didn't really talk too much about in the lab. And sometimes they'll throw a number up here, and then they'll throw something like this. And then we'll do like k over here. So just like before, what does this number do? What do you discover that did to it? Shift, so that moves it, shift, that's a horizontal shift. Horizontal shift. What did you figure out that k did to it? It's a vertical shift. It would move up the asymptote too, right? So if you have an asymptote of y equals 0, if that number is 3, it's going to move the asymptote to, if this were plus 3, it would move that asymptote up 3. So this number we didn't talk too much about. Yes, sir?
Shouldn't the range be y is greater than 0 because it never touches 0?
Yeah, that's what that means. So from the curvy line means it can't be 0, right?
But
so,
then it can't be infinity either.
Right, and the curvy line means it can't. So the curvy lines mean.
So wouldn't you want not a curvy line?
No.
It would be a break bracket.
Yeah, if it included 0, then it would have a square bracket on there. Okay? However you want to write. If you just wrote y is greater than or equals 0, that's fine. It means the same thing. But the curvy bracket means it doesn't include the endpoints. Okay? Okay, horizontal shift. Did you guys, all you did is play with a negative sign. If it's negative, what does that do to it? Flips. So if negative, right? If negative, flips it over which way? Flips over x axis. Right? Is that axis? And if it's what if it's a big number? We didn't really talk about that. But what would you think that a big number in front of there would do? Not a horizontal stretch. Like when you change this number, what happened to the function? It stretched it, right? So this, a number bigger than 1 in here would stretch it. A big number here also stretches it. So this can also stretch it vertically. It would make it get steeper, okay? And then, did you figure out what this number did? Sorry, I'm running out of room. Whoa, that's no good. What does this number do right here? Did you figure out that? If it's negative, what did it do? Yeah, that could flip it over y if it's negative, okay? And it could also stretch it if it's a number bigger than 1, and it would shrink it. It would make it go steeper faster if it's a number bigger than 1. But it can also flip, too much info, flip over y if negative. That's enough. We're not going to get too overly complicated. Flip over y if negative. And you kind of played with that Kobe Bryant graph, whatever it was, the Kobe Carmelo graph, and you figured out that it should have been shifted up, right? So going back, you should have figured out on that one, what did it look like? Let's go back to your lab. And what was it? So, for example, why is it not writing? Writing in a bit, there we go. So, for example, as you guys had, I had y equals negative 2, right? Negative 2 to the negative 3, and I didn't really want you to plug this into your calculator. 3x minus 1 plus 3, right? So what's a plus 3 going to do? Shift it up 3. So I would go up 1, 2, 3, and make an asymptote there. That's what I would do. That's not a very good asymptote. And then this thing, what's a negative going to do to it? It's going to flip it over the x-axis. So instead of going up this way, it's going to be kind of going down this way. But what's this going to do to it? So it's going to take what was going to be going up this way, and it's going to flip it. it's going to go, basically, I think it's going to look something like this, isn't it? Did you get something like that?
Yep.
Because it's flipped over the y-axis, it's flipped over the x-axis, it's stretched, that's kind of hard to tell. It's moved over -1, I guess. Well, it's actually moved +1 because it's negative, that's complicated. And up 3, something like that. I'm not going to make you do all these things at the same time, just like 1 or 2. Okay, so that's kind of the graphs of exponential functions. Do you know about rules of exponents? I'm going to tell you about rules of exponents. Rules of exponents. And I'm just going to kind of review this through examples because many of you already know this. So if you have 2, 2, 3 times 2 to the 5th, that's equal to 2 to the 8th. You add the exponents. Remember that? And division, you subtract the exponents. So if you have 5 to the 7th over 5 to the 2, that's equal to 5 to the 5th, right? Because there's 7 5s up here and 2 5s down here. And 2 of them would cancel out. So you subtract the exponents. But if you have a power to a power, like 2 to the 3rd to the 5th, that's equal to 2 to the 15th. And that's because what really this is 2 times 2 times 2, right? 5 times, yes? And so altogether you'd have 15 2's being multiplied by themselves, okay? And we know that if you raise something to a negative exponent, what's that equal to? 1 over x to the 3. And conversely, if you have something like 3 over n to the -5, how can I rewrite that? If you have a negative down here, how can I change that to have a positive exponent? N to the, that's 3 n to the +5. So if it's downstairs and it's negative, you can bring it upstairs and make it positive. Did you know that? Some of you knew that. Some of you forgot that. Anything fractional exponents. So if you have like the cube root of x, that can be written as x to the what? 1/3 power. And then, because you need some of these to solve exponential equations. And then a couple last things. Anything raised to the 0 is? Anything raised to the 0 is 1, except for 0 raised to the 0, and that is undefined. And because you can't really raise 0 to the 0, okay? Because it's the math doesn't work. And anything raised to the 1, 5 to the 1 is? Not 1, 5. What's pi raised to the 1? 5, okay? And so on. And that's about all you need to remember for rules of exponents. But why do you need to know that? You need to know that so that you can solve fun exponential equations, which are exponential equations are fun to solve. They are, they really are. I'm not kidding you. Exponent, so they'll say something like solve. Don't go to sleep yet. E squared equals e to the x. And they'll say solve for x. What's x? X equals 2. Right? That's pretty easy. Yeah. But wasn't that fun? But it gets better than that still. Right? So say for example. Now I bet you wouldn't know. That's not all. If you order now, we will also include this second problem, which has really fancy exponents in it. Right? 3x plus 1. Okay. And you can get it for 6 easy installments of only $9.95 a month. So, okay, yeah. So, anyone know how I do this? Jason knows.
I'm trying to factor down 16 until it equals 2.
Right. So what you want to do is you want to rewrite things so that they have the same base. This number here is called the base of exponential. So what Jason said, yep, you want to rewrite 16 as 2 to the 4th raised to the x power, right? And now using my rules of exponents, I could write this as 2 to the 3x plus 1 equals 2 to the 4x. So 3x plus 1 must be equal to 4x. And then you solve that, and you would get that x equals 1. Yeah? Yeah. So I had this friend in college. His name was Uli. Wait! I don't have time to tell you a story now.
Yes, you do.
Okay.
There's always time for stories.
There's always time for stories?
Yeah.
No. How did I get off of that topic? I don't know. So you guys out there in video land, you missed that dynamic story. You could come and see me in person to see it. So then we have another solving types of equations like this one. E to the negative x squared equals e, this is really a fun one, e to the x squared times 1 over e to the 3. And if you see one like this, you just say, I don't get this math stuff, I give up. Okay?
Yeah.
But you can use your rules of exponents to leave this side the same. And I don't know where you'd ever see a problem like this, but it's just kind of practice with exponents. How could I rewrite e to the x squared?
E to the 2x.
E to the 2x, like that, right? Because you multiply these exponents. How could I write e to the 1 over e to the 3? E to the negative 3. Okay, I bring it upstairs and I make it negative. Now I could rewrite this as e to the negative x. Oh, it shouldn't say x squared, I'm sorry. No, that is, sorry, I was good. E to the negative x squared equals, what do I do with these exponents? If the base is the same, then you add the exponent. So e to the 2x minus 3. And then you can say that minus x squared equals 2x minus 3. And then you bring everything on one side, and that gives you x squared plus 2x minus 3 equals 0. And then you try to factor that. And that factors 2, x what?
X can be negative 3 or 1.
X plus 3, x...
No, negative 3.
No, plus 3 minus 1, right? Equals 0, which means that x is equal to negative 3, or x is equal to 1. Okay? So that's one type of problem. One more, and then I'll be done. Oh! I forgot to talk about something.
To the back side of the note again.
That one's not too bad. I can do that one without my own. What if I see, I'm going to give you 2 more examples. I still have time. So if you see something like this, 1/2 to the 1 minus x, and all of these are a little bit different, equals 4. You say, I don't know how to do that. Does anyone have any ideas? How could I write 1/2 as a power of 2?
2 to the negative 1.
That's right. 2 to the negative 1 raised to the 1 minus x. How could I write 4 2 squared? So what you usually want to do is get these things to have the same base. And then you can distribute through the negative 1 over here because you multiply the exponents. So that becomes minus 1 times minus x, so it becomes x minus 1 because I distributed this through and flipped them over, equals 2 to the 2, so that must mean that x minus 1 equals 2, which means that x equals 3. Any questions? Okay. And the very last thing that I'm going to talk about is E. Does anyone know what E is?
Neutral. Natural.
E is the reciprocal of the natural log, not the reciprocal, the inverse of the natural log function, but e to the x is. But we're going to have some functions. So e to the x is a lot like 2 to the x, or 3 to the x, or 4 to the x, but e is a number that comes up in real life, and e is approximately equal to 2.7, I don't even remember, 2.173, and it's an irrational number, like pi, that goes on for never and ever. It represents the limit as n goes, I'm glad someone asked that, as n goes to infinity of 1 plus 1 over n raised to the n. Okay?
How is that necessary to know?
How is it? Because this E actually comes up a whole bunch in like applications of exponentials, like in radioactive decay in interest, that's compounding continuously with exponential growth, like if you put something in a petri dish or something like that, it comes up. So for example, if I were to plug, so this means as n gets very, very large. Please just let me finish, okay? So as n gets very, very large, this becomes 1. Let's just plug in 1 first, okay? 1 over 1 raised to the 1, and that becomes 2 to the 1, which is 2, right? But then let's go up an n to 2. So I go 1 plus 1/2 raised to the 2. What's 1 plus 1/2 in terms of a fraction? 3/2, which is squared, which is 9/4, which is that's 2.25, right? And then if I keep going with this, 1 plus 1 over 3 raised to the 3, right? That would be 9/3 cubed, which would be 27, not 27, 240.
Wait, no, it's 4/3.
Oh, sorry. 4/3, which would be 64, no, 64.
Oh, yes.
64 over 27, which is 2 point something. What is that?
So it can only ever get to...
Yeah, so it's never gonna get to bigger than 2.7.
Will it ever even get to it though?
Well, not exactly to it, but very, very close to it. And so you will be, and that works the same as other functions. So anyway, wait. Your homework is big,
No. Oh, it's
okay? And you want me to write it here?
Yeah.
It's on my website.
Which chapter is it?
It's, hold on. It's